Welcome back, tech enthusiasts. Today, we're diving into the world of microcontrollers to compare two popular programming languages, MicroPython and CircuitPython. For those unfamiliar, microcontrollers are like tiny computers that can be embedded into all sorts of projects, from custom keyboards and DIY robots to smart home devices and beyond. Both MicroPython and CircuitPython make it easier to program these microcontrollers using a more streamlined version of Python, but they each have their own unique strengths and weaknesses. In this video, we'll break down the key differences between MicroPython and CircuitPython, diving into their origins, features, use cases, and overall ease of use. By the end, you'll have a clear understanding of which language is right for your next microcontroller project. First up, we have MicroPython. This lean and efficient language was created by Damien George, a computer programmer with a PhD in quantum computing. He launched a successful Kickstarter campaign back in 2013, and the rest, as they say, is history. So, what makes MicroPython special? Well, it's all about bringing the power and versatility of Python to the world of microcontrollers. Python is known for its readability and beginner-friendliness, and MicroPython inherits these traits. But don't let the micro fool you. MicroPython is no slouch when it comes to performance. It's designed to be incredibly efficient, squeezing every last drop of performance out of even the most resource-constrained microcontrollers. This focus on efficiency makes MicroPython a popular choice for projects where performance is critical. Think about things like high-speed data logging, real-time control systems, or complex robotics projects. But MicroPython's appeal goes beyond just raw performance. It also boasts a very active and supportive community, constantly developing and improving the language. This active community has led to a wide range of libraries and modules, extending MicroPython's functionality even further. Whether you're working with sensors, networking protocols, or even machine learning algorithms, there's a good chance you'll find a MicroPython library to simplify your life. This wide range of libraries makes it a versatile choice for a variety of projects, from simple embedded systems to more complex IoT devices. However, MicroPython's flexibility can also be a double-edged sword. It can be a little more challenging for beginners to grasp compared to CircuitPython, especially if you're new to both Python and microcontrollers. Setting up and configuring MicroPython on a microcontroller can sometimes involve a bit more legwork, and you might find yourself digging through documentation or forums to get things up and running. But once you get past the initial learning curve, you'll be rewarded with a powerful and efficient language that can handle even the most demanding microcontroller projects. Overall, MicroPython is a fantastic choice for experienced makers and developers who prioritize performance, flexibility, and having a wide range of libraries at their disposal. Now let's move on to CircuitPython, a close relative of MicroPython, with a strong focus on beginner friendliness and ease of use. If you're just starting out with microcontrollers or want a more streamlined development experience, CircuitPython might be right up your alley. Developed by Adafruit, a company known for its beginner-friendly electronics and educational resources, CircuitPython takes the core principles of MicroPython and adds a layer of polish and simplicity. One of the things that sets CircuitPython apart is its plug-and-play nature. You can often simply connect your microcontroller to your computer and it'll pop up as a storage device with a pre-configured CircuitPython environment ready to go. This means you can start writing and uploading code almost instantly without having to worry about complex setup procedures or command line tools. It's a real time saver, especially for beginners who just want to jump in and start experimenting. CircuitPython also shines when it comes to hardware compatibility. Adafruit, the driving force behind CircuitPython, designs and manufactures a wide range of microcontroller boards and electronic components, all meticulously tested to work seamlessly with CircuitPython. This tight integration between hardware and software makes CircuitPython a dream to work with, especially if you're using Adafruit's own hardware products. You can find tons of example code, tutorials, and project guides on Adafruit's website, all tailored specifically for CircuitPython and their hardware. However, this focus on simplicity does come with a trade-off. CircuitPython might not be the best choice for resource-intensive projects where every last bit of performance matters. Similarly, while CircuitPython has a growing library ecosystem, it might not be as extensive as MicroPython's just yet. So if you're working with a less common sensor or communication protocol, you might have to put in a bit more effort to find the necessary libraries or write your own. Despite these minor drawbacks, CircuitPython is an excellent choice for beginners and anyone who wants a smooth and enjoyable microcontroller development experience. So, which one should you choose? It really depends on your needs and experience level. If you prioritize performance, flexibility, and have some programming experience under your belt, MicroPython might be the way to go. But if you're new to the world of microcontrollers, or prefer a more streamlined and beginner-friendly experience, CircuitPython is an excellent choice. No matter which one you choose, both MicroPython and CircuitPython offer a fantastic way to dive into the world of physical computing and bring your hardware projects to life. Let us know in the comments which one you prefer and why. Don't forget to like, subscribe, and hit the bell icon for more tech comparisons.